Hi, everyone. Welcome back. We're in sixth grade. We're in unit 7. This is lesson number 3. So you can see behind me, we are going to think today about horizontal ratio tables. In the past, earlier this year, and then even just in unit 7 earlier in our lessons, we've always had the vertical table where it just kind of goes up and down. We're very used to seeing that in math. But we could write our information horizontally as well. And so that's what we're doing today is we're going to continue our work with ratios, but we're going to be thinking about it in a horizontal table format to kind of get familiar with a different way that we can look at it. But it's the same thing, and our ratios work the same. So we've got some fun ratios to do today. So I hope you're excited about that. Today we're going to be comparing cherry juice and tangerine juice. Tangerines are a lot like oranges, so it's going to be a mixture of a cherry and tangerine, like a cherry orange kind of juice that we're making. And I'm kind of excited to try it because I've never thought about drinking cherry and orange juice together. So if you have availability to do that, you can do that. You could also just pretend or follow along with us, and that's okay too. So let's get to finding the cherry and the tangerine, and then let's take a look and see if we can fill out our chart. Okay, you can see I've got all my tools here. So I've got the two different colors. This is the cherry and the orange. I had to actually use orange. I didn't have tangerine, but orange and tangerine are very close to the same. So cherry and tangerine. And then I have a variety of measuring cups. Now, the tricky part is I know it would be probably easier if I had some of the same, like two of these or two of these, or something that could show you exactly the same. But I don't. So we're just going to have to be easygoing and realize that there is lots and lots of ways to measure, and our measuring things come in lots of different sizes and looks, and that's just how life is. So we've got to be a little bit easygoing about that. I will first of all fess up. I did not have the right juice at home. So instead of juice today, we will be working with, can you figure it out? It's Jello. Yep, it's Jello. So it's cheaper. First of all, Jello is a lot cheaper than juice if you're going to play around with it. If your family is willing to let you play around with math, this is a lot cheaper. And the colors are very vibrant, so we're going to be able to see it really easily. And plus, we just love Jello. So if you like Jello too, this can be a fun way to you can use it for math first, and then you can eat it later. So it's a win-win. Okay, so we need to talk about the ratios that these juices are in when we mix them. And I have never mixed Jello together before, so it's going to be really fun to see what it actually tastes like. So we've got to look back at the table. So hold on, I'm going to show you the table again. Okay, so here's what our ratio table looks like. Remember, it's horizontal, it's going side to side. So we know that 1 cup of cherry juice goes along with some mystery amount of tangerine, we don't know. Or we could do 1 cup of tangerine juice, and that goes along with some mystery amount of cherry that we don't know. So it's a little tricky to figure it out. How can we start when we don't have the information? Well, hopefully you're saying, look at this. We always have to start where we have the data. So we know that 8 cups of tangerine goes with 6 cups of cherry. Now you can tell I don't have 8 cups of tangerine, and I probably don't have 6 cups of cherry. So that doesn't work. But what we want to do then is we want to make the basic ratio. And if you think way back to the beginning of the year, we talked a little bit about how to do that, how to make a basic ratio. So hold on one second. I'm going to get ready and then I'll show you. Okay, so you might remember that if we have a ratio of 8 to 6, if we divide both of those by the same number, it'll get us down to a smaller amount that still has the same ratio. Now, in this case, we could divide them by 2 because both 8 and 6 we could divide by 2. If we did that, if we divided 8 by 2, we'd get 4. If we divided 6 by 2, we'd get 3. So now we know they're also in a 3 to 4 or a 4-to-3 ratio. Remember, it just depends on how you talk about it. It depends on how the words go. If you're talking about tangerine to cherry, it's 4-to-3. If you're talking about cherry to tangerine, it's 3-to-4. But we want to get something that helps us with 1. We want to get to 1 if we can. So how do we get from 4 to 1? Well, we divide by 4. 4 divided by 4 gets us to 1. Remember, if we do it to one part, we have to do the same thing. What's 3 divided by 4? Well, hope you're noticing that it's a fraction. 3 divided by 4, we can also write it this way. Remember, the fraction bar also means division. So 3 divided by 4, we can write it like that. And what is that? Well, it's 3/4. So 1 cup of tangerine juice is in the relationship with 3/4 of a cup of cherry juice. So it's 3/4 cherry to 1 tangerine. What if we wanted to go back the other way? What if we wanted to fill in this part? Here we're at 4 and we're at 3. This time we're trying to get the 3 to get to the 1. I'm going to get a different marker and I'll be right back. All right, so we still got the 8 and the 6. We changed it into 3 and 4 because those are smaller numbers. We don't have to, though. We can work with the 6 and the 8. We would just have to divide by whatever it is we want to divide by. So we're trying to get to 1 here, and we're at 6. So from 6 going to 1, we're going to divide by 6. If we divide by 6 to get here, we need to divide the 8 divided by 6. Well, that's a little harder, but we can still do it. What is 8 divided by 6? Well, if it helps you to think of it this way, you can. We can take 1 6 out, and there's 2 left. What do we do with those 2? In this case, we're going to make it into a fraction. We're talking about cooking, or in this case, making juice, but it's in the same area of food, so 2/6. Now, I can tell you that they do not show a 2/6 on any of my measuring cups. But if you simplify, they will. What does 2/6 simplify to? I hope you're saying 1/3. So it's 1 and 1/3. So now our basic ratio of cherry to tangerine is 1 to 1 1/3. Notice how we have 2 different basic ratios. It's a little tricky depending on how we say it. The ratio for cherry to tangerine is 1 to 1 1/3. The ratio for tangerine to cherry is 1 to 3/4. Let's see what that looks like when we make it. Okay, I'm on page 343, and we're looking at question number 1, and we're looking at the part A, the basic ratio of tangerine to cherry. So it wants us to start by looking at tangerine to cherry. So in that case, we need to measure out some tangerine and then measure out some cherry. So because we have generally more tangerine than we do cherry, I'm going to use the bigger cup for measuring the tangerine. Now, we said that tangerine was 1 cup. So I'm going to fill it up. Almost. All right, so there's 1 cup of tangerine. Now, that 1 cup of tangerine needs to go along with 3/4 of a cup of cherry. So I'm going to take a smaller measuring cup because I only need 3/4 of a cup. There's 3/4 of a cup. Can you see that? Oh yeah, there you go. 3/4 of a cup. 2. 1 cup. Now, I know when I tilted it like that, it's probably hard to see if I measured correctly, but I did a pretty good job. So there it is. Now, it's a little hard for us to tell because they're two different sizes, but we can see that this cup, measuring cup, is quite a bit bigger than this one. As a matter of fact, this is a 2-cup measuring cup, and this is a 1 cup. And we can see that this 1 cup, and this is 3/4 of a cup. So there's more orange than cherry. What that means is when we mix them together, the ratio, we want to stay the same. So we always want there to be more orange than cherry. That's what's keeping the same ratio means. Means if we did this once, if we did it twice, if we did it 3 times, we would still each time want there to be more orange than cherry and the same amount more. Not like a lot more or a little more, but rather the same mixture, the same recipe. So here's the recipe. No matter how many cups they need, this is the recipe we want to use. We might fill this 3 times, we might fill that 3 times. As a matter of fact, one of the ones says, what about 15? What if we were making such a huge batch? Maybe we were having a lot of people over for a party, or we were bringing it to school for some school event or something, but we still want it to taste the same. And that's the essence of ratios. So in this particular recipe, tangerine is 1 cup, cherry is 3/4 of a cup. But it is the same ratio. This is 1, this is 3 out of 4 parts. This is the same ratio as this, in that this is cherry is now 1, and tangerine, if we divide it into 3/3, that has 4/3. 4/3, and this is 1. That's how those ratios are the same relationship, but they just both, we bring them down to the basic ratio to 1. Okay, so for part A and B, for every 1 cup of tangerine juice, there's 3/4 of a cup of cherry. Then on C and D, for every 1 cup of cherry juice, there's 1 1/3 cups of tangerine juice. Now's the moment of truth. I'm going to put them together and taste it. Tell you what I think. Hold on. All right, here it goes. Here goes the cherry. Here goes the orange. See what this tastes like. It's good. Tastes like fruit punch, kind of. That's good. How do you think it is going to be as Jell-O? Have you ever tasted Jell-O without it being Jell-O-y? It's pretty good. All right, come right back, and we've got some flowers for you to talk about. Okay, before we go on to flowers, I actually wanted to just clarify something that's a little tricky. And the way our book has it written, and I was reading it, I was getting a little tricked. And I don't want you to be tricked. So I want to kind of clarify sort of some of the numbers that we did. So remember, we started with the 6 to 8 or 8 to 6, and we just cut those both in 2 to get 4/3. That was all what we needed to do. So everything we did, we needed to do. It's just tricky that the book is kind of having us think about almost like the unit rate here when it's taking us through A, B, C, D, as in cherry has 1. Remember, unit rate has 1. Since there's 2 of them, there would be 2 different unit rates, 1 to 1 1/3 or 1 to 3/4. But I don't want you to get confused about the basic ratio. Generally, when we think of basic ratios, we think of whole numbers generally. So this that we found at the very beginning is actually the basic ratio. When we divided it by 2 and got 4 to 3 or 3 to 4, and we can't take it any less than that without having it be a fraction, that's actually the basic ratio. And this is where we should write that. We wrote it over here just to help us think, but we really should be writing it over here. And then how the book is interpreting that for us is it's telling us that there's 3 to 4 or 4 to 3. So when you're talking about tangerine to cherry, it's 4 to 3. When it's cherry to tangerine, it's 3 to 4. These are more unit rates within the rate table. And I know that is a little confusing, but we'll see if we can clarify that as we go on. All right, now we get to stop and go to flowers. Okay, you may have seen these beautiful flowers sitting on my table earlier in one of the videos. So the daffodils actually came from my garden, which I was really excited to see. And then when I saw that this question, this part of our learning was focused around flowers, I actually ordered the tulips from the flower shop so that we could have lovely flowers in our house and also so that we could use them for math. So it's double duty. How cool is that? So these yellow ones are daffodils. If you're unfamiliar with daffodils, this is what they look like. And these pink ones are tulips, and that's what they look like. So let's look at question number 2, where it says a flower mix has 21 tulips and 14 daffodils. So I actually set this up exactly like that. There are 14 daffodils here, the yellow ones, and there are 21 tulips, the pink ones. Now, it wants us to say, this is a lovely mix, but what if we didn't want to buy so many flowers? What if we said, wow, this is gorgeous, but you know what, I just don't quite have enough money for all of those flowers. Or this is lovely, but I want to give them away to 2 different special people in my life. So I want to break them up into groups, but I like the ratio. I like how many tulips there are compared to how many daffodils. I think it's a good fit. That's where using ratios is really helpful. So let's take a look. We have 14 daffodils for every 21 tulips. Now you'll notice they didn't give us any other information. So we need to figure out what the basic ratio is, and then we can figure out if we wanted to break them into parts. So let's take a look. 21 and 14. Is there anything that we can cut both of those numbers up by the same number that would give us even numbers? Well, hopefully you're saying, well, sure. 14 and 21, those are both multiples of 7. What if we divided them both by 7? It's a really good idea. All right, so let's do that. 14 divided by 7 gives us 2. 21 divided by 7 gives us 3. Now, this is that basic ratio where it's a whole number that we were just talking about. Can it go any lower? It really can't. In fact, you could have 3/4 of a cup of juice, but you would not want 3/4 of a flour. That doesn't make sense. So in this case, it has to be a whole number. And that was part of the tricky part maybe with the juice, is that you can have a half a cup or 3/4 of a cup. You can't have 3/4 of a flour. Okay, so then we can't divide that any further and keep flowers. So the daffodils to tulips is 3-2. The tulips to daffodils, I'm sorry, the tulips to daffodils is 3-2. The daffodils to tulips is 2-3. Now, what that means then is if we decided to divide these flowers up, however many ways we wanted to, we would always want to make sure that we had 2 daffodils for every 3 tulips. Okay, so what would that be like? Well, if we were going to divide it up, we would literally say there's 1 daffodil, there's 1 tulip, there's 2 daffodils, there's 2 tulips. Now that's even, 2 and 2. But is our ratio even? No, our ratio tells us we need 1 more tulip to keep that same ratio. So there's 1 more tulip. Now, that's not the right vase, and those aren't the right size for the length of these stems. But you can see the ratio continues the same. We have 3 tulips and 2 daffodils, which is the same ratio as when we had them all together with 21 tulips and 14 daffodils. Now, would we have to stop here though? No, we wouldn't. We could say, okay, but I want to even keep sharing them out. So then we could say if tulips to daffodils is 3 to 2, but we wanted twice that many flowers, we could say, okay, well, let's multiply top and bottom both by 2. 3 times 2 is 6. 2 times 2 is 4. How about instead of 3 tulips and 2 daffodils, how about we had 6 tulips and 4 daffodils? Let's make that. So we already have 3. We already have 3 tulips, so we need 3 more. And we already have 2 daffodils, so we need 4. So we need 2 more. Now, that's beautiful. We need to cut them a little bit and arrange them a little bit, but that's a very lovely arrangement. So here we have 6 tulips and 4 daffodils. Now, our book gives us another challenge because that says, hold on, let me look at the numbers so I can tell you. All right, that is part F, question F on number 2. It says, how many daffodils would there be if we had 6 tulips? And we've answered that. There would be 4 daffodils. It also, though, wants us to say, what if we had 6 daffodils? How many tulips would there be? Well, let's see what that's going to be. We go back to our ratio table and we see we're starting with 2, but this time we want to get to 6. How did we get from 2 to 6? Well, instead of 2 daffodils, we want 6, so we put in 3 times as many. 2 and another 2 and another 2. So 2 times 3 is 6. Remember, if we do it to one part of the table, we've got to do it to the other part of the table. So what is 3 times 3? 3 groups of 3. Well, that's 9. So let's see what that looks like. I'm going to start with the tulips. There's 1, 2, 3, 4, 5, 6. So there's our 6 daffodils. Did I say tulips? We're starting with our daffodils. Sorry. There are 6 daffodils. This question wanted to know what it would be like if we had 6 daffodils. So those are our 6 daffodils. And then how many tulips did we say we need to make the same lovely ratio? 9. I'm going to pause and do that. Okay, so you can see that I put in 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 daffodils. And 1, 2, 3, 4, 5, 6, 7, 8. Whoops, 9. Did I put in 10? 2, 4, 6, 8, 9. No, and 9 tulips. And isn't that a lovely arrangement? It's smaller, but you can definitely see that it's still kind of the same ratio. And it is exactly the same ratio, actually. It's just kind of cool that you can also just kind of visually see that. When you look at the numbers, you can definitely tell that. 3 to 2. So even if we start from the very basic ratio, daffodils, let's look at this. This is the one we're looking at right now. Daffodils is 2. How do we get from 2 to 6? We multiplied it by 3. How did we get from 3 to 9? We multiplied it by 3. So as long as it's going up or down in the same number of increased groups or decreased groups, it stays at the same ratio. Good luck. See you next time.